We have been looking at kinematics, motion, study of motion. Um, in particular, we've been looking at the relationship between motion and graphs, using graphs as a way of describing motion. We're going to spend some time looking specifically at the problem of motion with constant acceleration. Um, Primarily reason for doing this is because constant acceleration motion occurs so frequently. So let's look at motion with constant acceleration, look at the graphs that result from this type of motion. Um, this is motion with constant acceleration. This is acceleration versus time graph. Here's a positive constant acceleration. Here's a negative constant acceleration. And here is a zero constant acceleration. In all cases, the acceleration is constant. And so all three motions would satisfy this requirement that the motion is in fact constant. Well, let's take a look at each of these cases individually. For the case of constant positive acceleration, question is, what does the corresponding graphs of velocity versus time and position versus time look like? Well, we know that acceleration is the slope of the velocity versus time graph, and so the velocity versus time graph should have a positive constant slope. So it means it should be a straight line. There it is, positive constant slope. Um, could I possibly take this straight line and shift it downwards into the negative part of the, starting with negative velocity? Would it still be constant acceleration, constant positive acceleration? Uh, Certainly, but I guess what we're looking at is the resulting position versus time graph for this velocity versus time graph. The velocity is going to start off positive and get more and more positive, which means the slope of the position versus time graph should start off positive and get more and more positive. So a curve of increasing slope. How about shifting it downward? Since the velocity only relates to the slope of the position versus time graph, I can take that same position versus time graph, shift it downward, and the slopes would be identical. So here again, the motion starts with a positive slope, and the slope only gets larger and larger. Here's another constant positive acceleration. In this case, the velocity starts off negative, um, increases to zero, and increases to positive values. Positive constant acceleration. What does the graph of position versus time graph look like here? Well, this means that the slope of the position graph must start off negative, must get increasingly close to zero, and then increasing in the positive direction. Something like that. Starts off negative, increasing closer to zero, and then increasing positive. Well, again, we can take the same graph and shift it downward, and we would still have a position versus time graph that is consistent with our velocity versus time graph. So these are possible graphs of constant positive acceleration. What about constant negative acceleration? Here's a graph of acceleration versus time, constant negative acceleration. Well, what does the velocity versus time graph look like? Well, the slope has to be constant, so a straight line with a negative slope, something like that. So here I have uh, something starting with negative velocity and getting more and more negative. So the position versus time graph looks something like this. So the slope starts off negative and gets more and more negative. Or once again, I can shift this to downward and still satisfy a slope that starts off negative and gets more and more negative. Well, what if our velocity versus time graph did not start with a negative velocity, but a positive velocity, and still have a slope that's negative, something like this? constant negative acceleration? Certainly. But here the velocity starts positive, gets smaller to zero, and then becomes more and more negative. What does the graph of position versus time correspond look like for this graph of velocity versus time? Well, I want the slope to start off positive and get smaller to zero and then become negative, something like that. Or I could again shift it downward, still satisfy the requirement that velocity starts off positive, decreases to zero, and continues to decrease negative. How about constant zero acceleration? Certainly constant acceleration. What does the graph of velocity versus time look like? Okay, that's a possibility, constant positive velocity, in which case the position versus time graph would have constant positive slope, or constant negative velocity, certainly constant acceleration, constant zero acceleration, in which case the position versus time graphs would have constant negative slope. How about constant zero velocity? Sure, that is also constant acceleration, in which case position versus time graph would look something like this. And so what we've done is looked at motions all involving constant acceleration. There are a myriad of possibilities. The important thing here is that you're not going to memorize everything, but from the fact that uh, motion has constant acceleration, you should be able to figure out what velocity and position versus time graphs look like for corresponding motion. A constant acceleration, we will be looking at many examples of constant acceleration.